Hello there, thanks for joining us. Good morning or indeed good afternoon, depending on where you're tuning in from. Welcome to the next session of the fantastic DCD Keeping IT Cool conference, the only event dedicated to data center cooling technology and the challenges of maintaining these higher density deployments that we're now seeing. I'm Dan Loosemore, the CMO here at DCD, and I'm delighted to act as chairman for the next hour or so here, and proud to be putting on this fantastic and free digital gathering for the industry at this challenging time with most of the world still coming out of lockdown and the global response to COVID-19 continuing. To those of you rejoining us, I hope you've enjoyed the earlier sessions yesterday and today. And to those of you for whom this is your first DCD Keeping IT Cool experience, welcome. And thanks for being one of over 1,600 individual session viewers that we're hosting across the week. Of course, those of you that know DCD well will also be aware that this is actually our 8th virtual conference this year so far, and the last of our Deeper Dive Summer Series. As the most visited media partner in the sector, we want to be leading the way, as ever, in online content, networking and best practice sharing. And indeed, since our first virtual event, DCD New York Spring Edition, at the beginning of April, over 15,000 of you have now tuned into the virtual series. So thank you ever so much for your support and interaction. Of course, with DCD face-to-face events not scheduled to return until the summer of 2021, all being well, we return in the autumn in September of this year with our flagship regional events, all virtual and all free. On your screen now in front of you, you'll see the link to the full calendar. You can go on now and register for any of those conferences, any of your choice for free, so there really is something for everyone. And it's also worth noting the new on-demand tab on datacenterdynamics.com, where you can delve into all of our presentations from the summer series at a time that suits you. There's no airplanes, no travel, no hotel queues, and the networking, we've hopefully got you covered on that front as well. A recent addition to our summer series, the networking platform powered by Swapcard, allows all delegates to connect at the click of a button, set up one-to-one meetings in the platform, and see the full attendee list. So you've got some visibility on your colleagues and peers joining you for these sessions. So please do, any owner-operators tuning in, service providers, colocation businesses, or engineering companies tuning in, do go and check it out. You can access it on your console in front of you now. Once you click through that link, at the top right-hand corner of the screen on the Swapcard platform, it'll say log in. You just have to put in the email that you registered for this conference with, and it'll recognize your credentials. So please do log in and give that a go. It provides a fantastic way of networking with 1,600 other attendees to this event over the next couple of days. With nothing further to do, I'll kick off this session. As always, a reminder that we like these sessions as interactive as possible. You can ask questions at any time using the Q&A module on your console. We'll get through as many of them as we possibly can during the session today. The following discussion has been sponsored by Iceotope, so big thanks to them for making all of this possible. As we delve into some of the drivers and evolutions in demand, really powering the adoption of liquid cooling. We've got a fantastic series of presenters lined up, 5 of the experts in data center cooling. I'll kick it across to yourself, Damien Wells, the Director of Spark Communications, to introduce the speakers in more detail and expertly steer us through the next hour or so. So Damien, over to you.
Thank you, Dan. Good afternoon, everybody. I think I'm a bit of a pretender, really. I run Spark Communications. We're a specialist media and social media and PR company which serves the data center sector. My job really is to facilitate the conversation between the real experts in liquid cooling. The job of this webinar is to try and give you a 360-degree perspective of the technology from the points of view of the data center designer, the data center operator, the manufacturer, and the technologist. We also want to talk about chassis level immersion liquid cooling and how it differs from other flavors of liquid cooling, where it can be applied to bring efficiencies and cooling certainty to existing as well as emerging applications. So as Dan said, I think we've got a bit of a stellar cast here. I'll just give you a quick introduction, starting with Malcolm Hale. Malcolm is a technical partner within Cundall's Critical Systems team, which specialises in the design of data centres and other mission critical facilities. Malcolm's special interest and expertise is in developing low energy cooling solutions for the industry, with a particular focus on system resilience and free cooling. He's also collaborated with several manufacturers on the development of new cooling approaches for our sector. Gerard Thibault has over 22 years direct experience in the industry and has been responsible for developing over $850 million worth of data center real estate, bringing online upwards of 200 megawatts capacity. Today, he's Chief Technology Officer at KO Data. The company develops advanced data centers for high-performance computing, which it describes as inspired by hyperscale and engineered for the cloud, AI, and enterprise. KO's 35 megawatt data center campus is at the heart of the UK innovation corridor, which it underpins with optimized and world-class digital infrastructure. As chief engineer at Schneider Electric, Tony Day was influential in the company's move towards standardized modular infrastructure to advance the industrialization of the data center sector, as well as provide more predictable performance at the physical layer, and that's a mouthful. Tony has an extensive CV, which I think you can access at the bottom of your screen if you'd like to read it, but really just to say that he is the inventor of in-row cooling and holds all patents. David Craig is a serial entrepreneur and CEO of Iceotope, a position which he's held for the last 5 years. During his tenure, the company has advanced and developed its liquid cooling products and solutions, and by listening to customers and innovating to make the technology more applicable and cost-effective in a wider number of applications, both in data centers and distributed edge computing locations. So with the introductions done, Malcolm, I'm going to ask you the first question. And the first question is, what are the specific challenges clients are trying to address when they speak to Cundall about liquid cooling?
That's a good question. Many and varied. We've got colo developers, wholesale developers who are seeing an emerging market for high density offerings, and they perceive liquid cooling as a way of delivering that. Some are looking at creating dedicated high-density liquid-cooled suites within their facilities, and others are looking at integrating liquid-cooled racks into existing data centers. And then, we've also got end users that we've spoken to who've got requirements for very high-density specialist applications. People are doing weather modeling and CGI and whatever. And I think what's sitting behind this is this sort of general trend power density that's been going on for some time. I mean, if you go back 8 to 10 years, your average rack power density was about 4 to 5 kilowatts, whereas today it's closer to 7 to 10 kilowatts and going upwards. And this is where liquid cooling starts to come into play, because this ongoing increase in power density is starting to push up against the limits of what can be sensibly achieved in a conventional air-cooled data center. If we take this scenario here on the screen, 3.7 megawatt data hall with 7 kilowatt racks. Air velocity down the cold aisle is about 2.5 meters per second with this particular arrangement, single-sided ventilation, and that all works fine. But if you get a customer who turns up with some very high-density racks, say 24 kilowatt racks, and you try and convert one of those aisles to high density, because these high density racks generally need to be clustered together, then you immediately start to run into airflow issues, and the whole thing starts to become quite difficult. And what you have to do is move the racks apart to allow for more air movement around them, and you end up with a cluster of high density racks as an island at one end of the data hall, surrounded by a lot of empty space, which isn't really a sort of a good arrangement. If you just want to advance the slide, David.
Sorry about that. Yep.
Yeah. So if we look at, if we convert some of those racks to liquid cooling, then, all of these problems start to go away. I mean, you can maintain a number of lower density air-cooled racks in the space without compromising the airflow. And actually, if you've got the power available within the same footprint of the data hall, you could increase the overall capacity of the room. So, that for a colo operator is trying to maximize the return on the investment of the facility, that starts to become quite compelling.
Got you. In order to address the challenges then and achieve widespread adoption, what do you think liquid cooling vendors need to do, Malcolm?
Do you want to just, shall I advance it? Hold on. Yeah, here we go. Barriers to adoption. Yes, that's another good question. I mean, there's certainly some challenges that need to be overcome. I mean, these are my top 5 concerns over bringing water into the critical space. That's a lot of people go to some lengths to avoid that, and the complexity that comes from bringing water up to the rack. The thing about air, if you spill air, it doesn't make a nasty mess on the floor, which is more than could be said for liquid cooling. But these things can be overcome. I mean, we looked at double contained pipe work, running pipes below floors, negative pressure pumping. I mean, vendors need to look at how they can mitigate those sorts of risks and simplify the maintenance process. And I think certainly the Iceotope chassis level cooling is quite good in that regard, because the chassis withdraws from manifolds. It's got self-sealing connections. It's quite a seamless offering. It doesn't require you to call out a plumber if something goes wrong. The 2 cooling systems rather than 1, that's another one that's constantly played out. You've got a mixture of air-cooled and liquid-cooled racks. There's a perception that that's 2 systems means double the cost. In actual fact, it doesn't necessarily mean that, because the higher density cooling systems that you've got for liquid-cooled racks are operating at high temperatures. You don't need chillers. Usually you don't even need to have evaporative cooling on the heat rejection. The heat has got a smaller footprint, and if you've got a cluster of liquid cooled as opposed to air cooled, all air cooled, then your air cooling system is reduced in size. So, OPEX and CAPEX doesn't need to be a big issue. Proprietary technology, that's another one that I think, again, is a perception that's perhaps a throwback to when liquid cooling was associated with big mainframe computers. These days, the liquid cooling offerings that I'm aware of are generally IT vendor neutral. You can put pretty much anybody's server into these things, and it'll work. And I think vendors need to get that message across, that they're not tying their customers into a single source of IT supply. Dielectric fluids, that's another one. Again, that's a perception. Some people believe that oil-filled baths and whatever, that must be toxic or it's a fire risk, whereas in reality it's these are low GWP, zero ozone depleting and non-flammable fluids. But again, vendors need to get that message across.
Got you. Okay. And are there incentives for adopting some level of liquid cooling sooner rather than later?
Absolutely, yeah. I think it's certainly a technology that's coming down the road, and I think the industry needs to gear itself up for it. I think the trend in increasing rack power density is not going to stop. This is something that's going to continue, and I can imagine, a sort of a move away from, well, I mean, hyperscale is obviously going to continue, but I could see increasingly small edge data centers, very high density, liquid cooled in an urban environment. This is what edge is all about. And, it's not hard to imagine, this being part of this digital cities thing where you've got these facilities that are powered by renewable sources and then are exporting their waste heat into local district heating networks. So, you get to use the energy twice. I mean, I've had some experience with waste heat recovery from data centers on a hyperscale, and say, it would be a lot easier to do it with liquid cooling than it is to do it with air cooling. And finally, I believe that owners and operators will eventually wake up to the OPEX and CAPEX benefits of liquid cooling and see that there's actually some savings to be made.
Thanks very much, Malcolm. Let's just move on and talk to Gerard for a second. Gerard, do you believe that operators need to make large-scale switch to liquid cooling, or do you think it'll be feasible to run it alongside existing air cooling? You're on mute, Gerard.
My apologies. That's one of the problems of this virtual world, isn't it? You get in train. So, yeah, thanks for the question, Damien. And for those of you who don't know, Malcolm and I have worked on a number of projects together using air heat rejection, water heat rejection, but as yet just air transfer within the data center. But going back to your question, Damien, absolutely, I think we're going to see, particularly in the wholesale colo market that we represent, more of a gradual change. I don't think it's going to be an overnight shift to liquid cooling straight away. Obviously, hyperscalers have got their own platforms to think about, and they can engineer accordingly. And clearly, we can develop on behalf of them and provide 100% cooled rooms. But what I see is effectively this technology enabling the better utilization of data centers. So we often end up with pockets of spare space that we can't use, where we've installed low-density customers. If you see on the screen there, there's a small cluster there with some piping, red and blue piping, taking heat away to external heat rejection systems. Yet in front of it, we've got 6 cabinets there that actually are based on 5 kilowatts a cab. And that's, effectively where I think the sort of design lives at the moment for air-cooled is 5, 7, moving upwards towards 10. But clearly we do see a lot of applications where the sort of 25 kilowatts a cab exists, as Malcolm talked to. And we are seeing that sort of drives up as well. So, it definitely, after all these years, the 20 years of people saying that densities are going up, they definitely are moving up. And we're seeing a number of ways of dealing with that, and it could be either rear door heat exchangers converting the air into water rejection, or indeed what we're sort of focused around now here, immersion level cooling, or even onboard heat sinks and water cooling.
Got you. Are there what are the sorts of workloads that liquid cooling can handle that can't necessarily be achieved through air cooling?
Well, I guess ultimately it's higher density. So, as we said, the power densities are rising. So it's really sort of software that's being driven by, I guess, the sort of artificial intelligence and machine learning sort of systems that we're seeing coming in. So it's very application specific, but we are seeing sort of large infrastructures going in, platforms going in that do sort of predictive modeling for all sorts of things. It could be weather, other dynamic analysis, and they have huge sort of power draws, and we're talking about sort of 25 kilowatts religiously per cabinet, and as Malcolm alluded to, with the necessity to be directly located next to each other. So that drives the overall sort of density up way up. In reality, that's because of the speed of communication between the different processes that are running. So that's why they need to be co-located together. I think one of the things we've got to be careful about is how we actually provide that sort of 13 times density uplift from sort of, say, an average of 65 kilowatts a cab down from the sort of 5 kilowatts a cab, and how we get power to it. We're seeing potential deployments of 45, 62, 125 kilowatts a cab. 125 kilowatts is 180 amps. The largest connector you get on BS4343 is 125 amps, and the cable is pretty large. So we've got some thought to do around how we practically use this technology going forwards. But I think certainly sort of the 40 to 60 kilowatts a cab is quite doable.
Thanks very much. Gerard, how do you see factors like heat reuse driving adoption? Do you think they're important?
Absolutely. I mean, one of the things that we've been looking at recently is the reuse of energy from an immersion cooling system. One of the things that drives sustainability is the good old 3 R's. Recycle, reuse, reduce, or sorry, not probably the right order there, but the idea that we could potentially reuse the energy that's already powered the IT platforms within these data centers, I think is absolutely something that we need to explore and exploit. We've used what we think is the most sort of efficient means of cooling, which is indirect air. So we're using very little energy, no refrigeration, so bring some sustainability with it. But trying to regain heat back from that process with 36-degree air is not that efficient and requires further energy to absolutely uplift it to something that could be used by surrounding sources. What we see is that the water usage directly using chips that reject heat directly into the water allows us to really start to think about those digital cities that we've heard about and sort of have heat sinks that are, offices, conference rooms, homes and all that sort of thing. But I guess one thing we need is government to sort of play into that to sort of help developers provide that network to use.
Got you. Okay. Thank you very much. Thanks very much, Gerard. Tony Day, liquid cooling isn't very new, is it? What, in your opinion, is driving the renewed push towards it?
Well, firstly, the impact of continuing miniaturization and the resulting densification at all levels within the IT hardware to deliver ever greater performance. The growing application of ICT across all aspects of our everyday and organisational lives, and some of the digital technology trends in addition to cloud that are creating this greater performance demand. Yes, we can push air cooling to greater densities than, say, the 25 kilowatts that TGG suggests, but rear door heat exchangers will get us to 40 kilowatts. We have in-row units we've taken up to 67 kilowatts. And at server, rack and row level, CFD modelling software has allowed optimisation of the design of heat sinks and airflow paths, which already considerably extended the life of air cooling technology. But each increase comes at a cost in terms of efficiency and effectiveness. A denser cooling fluid, such as water, has over 3,400 times greater volumetric heat capacity and 24 times greater thermal conductivity than air. So even dielectric heat transfer fluids have ratios of around 1,300 and 2.5 times respectively. With air-cooled racks, as rack densities increase, potentially reducing the overall rack count, the ratio of the cooling plant to the number of racks also increases, diminishing the gains of higher density racks. Due to the better thermophysical properties of liquids compared to air, liquids provide a significant reduction in overall data center footprint through IT hardware compaction. To date, there have been significant improvements in energy efficiency at both data centers and networks. This could be attributed to various efficiency improvements, but also the large shift to hosting cloud-based services in hyperscale data centers. But these gains have been more than offset by the increasing consumption of services. The trend to push electricity consumption onto the network and data center infrastructure means energy costs are less transparent to the ever-expectant connected customer. For example, both these areas represent the largest share of energy consumption over the lifetime of mobile devices like tablets, smartphones, accounting for at least 90% of the total energy use, including manufacturing and charging. Some of the ICT trends already noted on this slide, along with the changing patterns of increasing use arising during the current pandemic, most likely suggest there needs to be less focus on optimal geographic locations for data centers to achieve best-in-class air cooling efficiency. Rather, liquid cooling permits effective, efficient, and sustainable IT solutions to be deployed across almost anywhere they're required globally. And finally, the new ratio of compacted IT hardware to infrastructure plant will require a serious rethink for future facilities regarding overall data center layout configuration. With the highly granular and scalable infrastructure possible with liquid cooling, hopefully this might also help to resolve the perennial issue of poor data center utilization.
Thanks very much, Tony. In your time at Schneider, what were the factors that led the company to backing Iceotope as opposed to other vendors?
There are a number of reasons, some of which are shown on this slide, and I'll just call out a few. So a key requirement was the ease of deployment into existing data center environments. So using standard industry IT hardware formats, equipment racks, server lifters, not requiring installation of special hoists or cleaning equipment service carts, IT hardware to be agnostic, able to use any adapted air-cooled or any purpose-designed liquid-cooled design device. Single-phase immersion process, avoiding the added complication of two-phased tank immersion solutions, and the potential issues that you get around boiling the dielectric. Ability to utilize maximum ASHRAE W4 FWS water supply temperatures to get the most efficient requirements. Also, a single-phase convection solution without the filtration issues normally associated with normal microchannel cold plates. Iceotope can offer either of these or a hybrid combination of both solutions. Very small quantities of dielectric per server, and hence rack deployment, hence per rack, which has deployment implications, particularly for large or very large at scale facilities like hyperscalers, where server refresh might involve perhaps 1,000 preloaded racks at a time being rolled in by the integrator. So immersion tanks have to be filled in situ with dielectric, perhaps 400 litres for a 24 RMU or 900 litres for a 42 RMU tank. The benign liquid environment improves IT component life and offers the possibility of sealed for life servers, which could help to reduce or remove break-fix operations. And lastly, but most importantly, I think, is the greater freedom for the IT hardware designer regarding board layout, shape and stack by removing the restriction to locate components by position and orientation based upon their thermal load density. Now, due to the unique manner of distributing the dielectric coolant within the enclosed immersive chassis that Iceotope produce, all convective and to some degree all immersive tank solutions, they're still limited by serial air or liquid flow, shadow flow effects.
Got you. Thanks very much for that run through. I think it's very interesting. David Craig.
Hello.
How are you doing, David?
I'm good, thank you.
Good. With the liquid cooling market getting more and more crowded, what sets Iceotope's technology apart?
Yeah, thanks for the question. I'd start with what's different about us as a company first and foremost, because I think it's common at this stage in an industry where there's lots of entrants and lots of people getting busy, where frankly people have got a technology, that's looking for a problem. And we saw that and we stepped back and said, how do we look actually, for a problem to solve and gear the technology towards the problem, not find, a bunch of technology and then try and fit it to a problem later. With that, it allowed us to really understand that actually, just making hot things colder is fairly well understood. But we're at this real crossroads, where the sustainability issues, the reputational issues, this ever-increasing density and such like create both challenges for people, but also opportunities, as we see in the edge and various other places. So the first thing we did was to say, if you were going to design a set of liquid cooling technologies, how do you make sure you allow people to both solve the problem but capitalise on the benefits of the future? And also recognising that this is an industry with $1 trillion of investment and 40 years of value engineering. How do you deliver the technology in a way that's as familiar as possible, as server agnostic, coolant agnostic as possible, such that the customer can begin the journey towards the new stuff in the most familiar experience possible, working with the same supply chain, with the same vendors, with the same consultants, and so on and so on. So we thought that was really important. And that led us to what we call chassis level cooling. So if you advance the slide, did you hear me, Damien? Thank you. So this slide is actually independently developed. One of the things we did recognise is that there are approaches which either involve blowing air, or chip, direct-to-chip cooling, or the kind of immersion tubs, and they all have their great strengths, but they also have significant weaknesses. And really, what we wanted to do is kind of almost take the Venn diagram and deliver up something that ticked all the boxes. So we created an environment which sits in 1U, 2U, 3U, 4U, doesn't matter, standard racks, which you put any server into, which you use any coolant in, which works with ASHRAE W4, which is incredibly serviceable. We can have hot swap ability, we can have servers running and serviced as you go, and we cool the entire stack. So servers, switches, spinning disks, and in any scale, so from hyperscale to the edge. So we're the only liquid cooling technology that you could use across the whole estate, and across every use case that sits there. So I think, market-focused design, a technology that's incredibly flexible, and a business model that's incredibly flexible, that gives the customer a solution and control of the solution, and allows us to kind of get out of the way of the customer whilst helping them.
Thanks very much. David, what do you think are the biggest challenges that still need to overcome?
Yeah, so, there are several, and Malcolm, Gerard and Tony have kind of talked about several of them, but back to that kind of big risk-averse market which is out there, and rightly so. First and foremost, people see it as a perceived cost. Often these things are perceived as additional to. And what's actually happening is that we're starting to really be able to explain better the cost of ownership benefits of liquid cooling. And we are now at a point where liquid cooling absolutely can be cheaper than air cooling. It can save in CapEx and OpEx benefits, and those things are being better understood, better measured, and we can really start to take that to people so that it removes that cost risk. Back to the general, risk as an overall category, how people feel. Well, there's risk of failure, there's risk of reputation. There's a whole set of worries that people have around that, and we're changing that also as we go. As more people deploy, more people get use cases and get that sense that this works for them. And again, as an industry, we're gradually managing to solve those problems, and certainly the scale of work we're doing is solving these challenges on a significant level from hyperscale to edge. I think people have a lot of concerns around serviceability. I would say probably 95% of the conversation that we have takes kind of cooling as, takes it as read, and it's actually, how does it fit? Where does it work? How will my people interact with it? It's those kind of questions that really matter. And again, we've really worked hard to make sure that people understand you can, interact with this stuff often much more simply than in air, and less often because it's much, much more reliable. And that, that benefit applies anywhere in the world, particularly by being a sealed chassis. We're tamper-proof. We're impervious to heat, dust, and humidity. We're able to deploy in the cupboard under the stairs or to the hyperscale data center, and we can reduce those service intervals, but also make servicing super simple, super quick. I think the final concern people have, and it'll depend on where you sit, but a lot of people worry about the supply chain. There's a huge number of companies here who've got, multi-billion-dollar supply chains. And the last thing they want is to rely on a small company or a single source. And that's one of the things we really sat down and thought about, and hence we've focused towards a licensing model so that we don't get in the way of the supply chain. If you need to buy components and do so, you do. You can buy your coolants from anywhere, you can buy your servers from anywhere, and you can deploy the designs that you want to deploy, and a range of technologies that we can work with the client to allow them to deploy in any scale. So there will be others out there, but I think these are the main blockers that people have. And, I believe at Iceotope we've definitely got answers to these questions for people, and we can begin certainly building on and delivering the promise of liquid cooling that's been, long hankered after.
Excellent. Thanks very much for that, David. I'm gonna pitch the first one at Gerard if you're available. Gerard, you spoke about using liquid cooling essentially to unlock stranded space in your data center by using the room neutral solution. Can you give us an idea of what sort of payback or ROI you might generate using this sort of tactical deployment?
Good question. I mean, I guess some of it's going to be really dependent on what we can do with that waste energy. If we're adopting the sort of normal procedure where we provide heat rejection locally at the site, then effectively we're going to be looking at sort of recovering our investments over those sort of 10 to 15 year periods when the equipment comes up for its life cycle replacement. I think one of the things that we could be looking at is if we can reuse the heat off-site. There's a whole potential to explore a recharge model for that energy, albeit at a discounted price, so that the local heat sinks can take benefit of taking reduced cost energy, but the income from that can then offset the fact that you would obviously need to provide the heat rejection locally as well as the heat sink, so that when the heat sink isn't available to take the energy, you can still reject the heat and run your operation successfully.
Thanks very much, Gerard. Heat reuse seems to be a common theme for some of the questions. Malcolm, someone has asked, in hot and humid countries like India, how can heat from servers be reused?
Yeah, that's a good one. I mean, there may be in a place like India or Singapore. I mean, I'm doing a project in Singapore at the moment, and the requirement for waste heat in locations like that is obviously much less than what it is in Northern Europe, North America. There may be some applications in hot water heating or some process work, laundry, something like that, where it could be potentially used. Perhaps not, though. I think another more pertinent question to be asked on that point is, in hot and humid countries like India or Singapore, if you had to cool your data center with air, what kind of an energy-intensive process would you have to put in place to do that? If you're cooling your data center with liquid, where you're running your cooling loops at 45 degrees C, even in India, you may avoid the use of energy-intensive chillers. You possibly would need to have some evaporative cooling or something like that, but it would be an easier task than to produce cooling air at 24 degrees C or 26 degrees C into your cold aisle.
Thanks very much, Malcolm. Got an interesting question here. What do the panelists see as the biggest barrier to broader adoption in general purpose data center applications? We talk a lot about high density, but how about for these lower density applications, which are obviously ubiquitous? And I don't know who to pitch that at. Who wants to pick that up?
I'd be happy enough to have a stab at it, Damien, and anyone else can feel free to, jump in, particularly if I'm talking rubbish. I think the general purpose one, this is almost like the crossing the chasm thing. We're at that point where we've gotten past if liquid cooling. It's definitely into the land of when liquid cooling, and the journey has started. And there are obvious use cases where there's just serious hay to be made by adopters of the technology. By the time you get to the general purpose data center, the enterprise data center, that kind of thing, it's logical that volume deployment there comes when, you know, we're a few generations into the technology, if you like, you know, where tier one vendors are actually pre-shipping servers which are liquid cooled ready and doing so in volume. So, you know, market demand will help push that, and also deployment. So I don't think it's time for it just yet, but it doesn't mean that it won't represent, you know, 15, 20% of the market in, you know, any few years' time. And then it will start to become more ubiquitous and more easily deployed, because the cost profiles will have been improved, the engineering understanding will be there, the risk will be reduced, and the, you know, frankly, people who just want to get on running their normal businesses and don't really want to think about IT will just be able to deploy it.
Yeah, if I could just chip in there, Damien, sort of more perhaps on a sort of practical sort of point, that I think people in the IT business are very cautious. You know, they react to change quite slowly. You know, even in changing of chilled water temperatures from 612 all the way up to 2025 and 2027, and then indirect air cooling, it's taken a long time for that to come through. So there's a natural sort of handoff. But the same, I think, is probably due of SLA. So people are buying data centers now much more on SLA, so less worried about what goes on behind the curtain. So I think it then becomes up for us to lead and actually say, don't worry about that, that's our core business. You just tell us what you want in terms of running your workload, and we'll sort it.
Yeah, that's very interesting, Gerald. In fact, in an earlier session, Lex Coors said that Interaction had 56 chilled water data centers that were essentially liquid ready. How easy do you think it's going to be for, you know, colocation service providers to transition to liquid cooling?
Well, I guess it depends on what the chilled water systems are set for, but essentially it could be quite straightforward. If you've got a sort of plate heat exchanger between different temperature loops, that's fine. But what I would say is if it's the older type chilled water working down at lower temperatures, then it's still going to absorb far more energy than it ought to. As Malcolm referred to, often we can use temperatures direct from these immersion cooling systems without the need even for adiabatics, let alone chillers. Malcolm, I don't know if you want to add to that.
Yeah, that's absolutely right, Jared. I mean, the temperatures that we're operating at for, you know, for Northern Europe, you probably wouldn't need to have evaporative cooling for, well, all of the air maybe, and, you know, only for a very small proportion of the air in hotter parts of Europe, you know, a few hours during the peak summer period. So you could have a situation where, you know, you just have interposing plate heat exchangers that bypass the chiller plant and go direct to dry air coolers or cooling towers or something like that, and dissipate the heat that way.
Just on that point, the experience when I was at Schneider, the whole point was to use this for general compute, not to be using it for HPC applications. That was the whole point. But users that have actually put in operational test facilities already, particularly some of the people in the financial markets who are very conservative and all about safety and reliability, true mission critical applications, they've tended to add into their existing plant so they have a discrete dry cooler and an FWS circuit through a CDU, and then through the TS secondary loop up to the rack, and then connection into the distribution manifolds on the rack for the actual cooling. So, you know, that seems to be a pattern with most people. They have that set up. In some situations, particularly edge sites, where you can quite sensibly omit the CDU and have even the heat rejection dry cooler directly coupled into the secondary loop, because and get the efficiency gains there, because you don't have lots of other equipment on there that has different requirements. So it's all about, if you're connecting into existing loops that have operating systems that are operating at very different temperatures, very different pressures. If you don't have that, if you set up a discrete circuit, which is the way that most people want to do it anyway, so they can actually evaluate the equipment correctly. And it's easy to add in and change things around in that scenario as well. Gives you a lot of flexibility. So that seems to be the way most people are going at the moment.
Terrific. And Tony, I guess you can buy that cooling design if people want it.
Oh yeah, yeah.
Brilliant. Okay. Well, look, we're over time. Thanks very much, everybody, for staying on to hear the questions answered. Our thanks to Tony and to Gerard and to Malcolm and, of course, to David and to Iceotope for sponsoring this session. Please enjoy the rest of your afternoons.